Somewhere inside a single photograph, more than 60 million stars are staring back at you, and every single one of them belongs to our own galaxy. This isn't a simulation. It isn't an artist's rendering. It's real light, captured by a real telescope, aimed directly at the crowded, blazing heart of the Milky Way. For years, this exact region was considered nearly impossible to photograph properly. Too bright, too crowded, too chaotic for most instruments to handle without becoming completely overwhelmed. Then one telescope, originally built for a completely different job, turned around, pointed itself toward home, and captured something nobody had ever managed to capture before. So what exactly did this new image reveal? Why couldn't earlier telescopes pull this off? And why are astronomers calling this snapshot one of the most useful images ever taken of our galaxy? Stick around because the story behind this photograph is just as fascinating as the picture itself. Here's why this matters right now. This new image isn't just a beautiful picture to admire and scroll past. It's a genuine scientific tool, one astronomers are already using to search for hidden planets, study invisible dark matter, and prepare for missions that haven't even launched yet. By the end of this video, you'll understand exactly what makes this image so special, why it took a telescope never designed for this job to finally pull it off, and what scientists plan to do with it next. Let's start with the telescope responsible for this incredible shot because its main job has almost nothing to do with taking pretty pictures of stars. Meet Euclid, a space telescope built and operated by the European Space Agency. Euclid wasn't designed to photograph glowing star fields or colorful nebulae for the public. Its actual mission is far stranger, and in some ways, far more ambitious. Euclid exists to study two of the most mysterious substances in the entire universe. Part 5 brings us to what happens next, because this image isn't really the end of the story. In many ways, it's a preview of something much bigger still to come. This exact region of sky that Euclid photographed isn't a random target. According to NASA, the same crowded field Euclid captured is precisely the area that NASA's upcoming Nancy Grace Roman Space Telescope is planned to observe repeatedly over the coming years once it launches, specifically hunting for exoplanets using that same microlensing technique. Euclid's new image, in other words, functions almost like a detailed preview. A cosmic dress rehearsal for the much longer, more intensive survey Roman is expected to conduct once it begins operating. That connection matters enormously for planet hunters. Microlensing is uniquely good at detecting a category of planets that other search methods often miss entirely. Worlds orbiting relatively far from their host stars, similar to how Neptune orbits far from our own sun, and even rogue planets that have been flung out of their original star systems altogether, drifting alone through the galaxy with no host star at all. Ground-based telescopes have already used this technique to find hundreds of planets, but a dedicated space telescope, observing continuously, without interruptions from weather or daylight, is expected to uncover vastly more. Beyond planet hunting, this new image also carries broader value for understanding the structure of our own galaxy. The Milky Way's crowded central bulge holds important clues about how galaxies form and evolve over billions of years. And having this much visual detail available for scientists to study gives researchers an entirely new dataset to mine for years to come. There's also something worth appreciating on a more personal level here. Euclid wasn't built for this. Its actual mission, hunting the invisible fingerprints of dark matter and dark energy across billions of distant galaxies, remains its primary job. And that work continues in the background of this entire story. This particular image exists because scientists recognized an opportunity, borrowed an incredibly capable instrument for just 26 hours, and pointed it somewhere unexpected. Sometimes the most striking scientific images come not from a telescope's main purpose, but from a clever, well-timed detour. So here's the honest answer to the question this video started with. What did Euclid actually reveal? A telescope designed to study the invisible architecture of the entire universe turned around for just one day and gave humanity its most detailed visible light look yet at the crowded, glowing heart of our own galactic home. 60 million stars, captured in stunning clarity, and still, remarkably, barely a fraction of everything actually out there. It's a reminder of two things at once. How far our technology has come, capable of resolving individual stars across an area equal to 22 full moons in a single day of observing. And how vast our own galaxy still remains, so enormous that even a landmark achievement like this one only shows us the faintest sliver of the whole picture. Somewhere in that crowded, glowing image, hidden among 60 million points of light, there are almost certainly planets nobody has discovered yet, quietly waiting for the next telescope and the next careful astronomer to notice them. What do you think astronomers will find once they dig deeper into this image, and once Roman's dedicated survey finally begins? Let us know what you think in the comments below. And if this story gave you a new appreciation for just how much of our own galaxy is still waiting to be discovered, make sure to like this video and subscribe for more true stories from the edge of what we can see. Dark matter and dark energy, invisible forces that together are believed to make up the vast majority of everything that exists. Despite the fact that no telescope has ever directly seen either one, to hunt for the fingerprints of these invisible forces, Euclid spends most of its time staring deep into space, mapping billions of faraway galaxies scattered across enormous stretches of the sky, tracing how their light bends and distorts due to gravity, revealing clues about the unseen scaffolding holding the universe together. In other words, Euclid was built to look outward, away from our own galaxy, toward the largest, most distant structures in the cosmos. So why did a telescope built for exactly that mission suddenly turn around and photograph our own galactic backyard instead? Part 2 of this story is where things get genuinely interesting, because the answer involves a problem that had frustrated astronomers for years: the incredibly crowded, blindingly bright center of the Milky Way itself. At the heart of our galaxy sits a dense, glowing region astronomers call the galactic bulge, packed with an almost unimaginable concentration of stars, all crammed together far more tightly than anywhere in our own quieter corner of the galaxy. For scientists interested in a specific technique called microlensing, a method used to detect distant planets by watching how their gravity subtly bends and magnifies starlight, the galactic bulge is exactly where you want to look. Here's the catch. Photographing that region properly requires a telescope capable of two very different things at once: extreme sensitivity to detect faint light, and the ability to avoid being completely blinded by the sheer brightness and crowding of the scene. Most telescopes struggle badly with that particular combination. Either they lack the resolution to tell individual stars apart in such a packed field, or the intense brightness overwhelms their instruments entirely. For nearly 20 years, astronomers using ground-based telescopes had already discovered almost 300 exoplanets using this exact microlensing technique, always aiming toward the galaxy's crowded center. But those observations came with real limitations, and scientists knew a space-based telescope with the right combination of sharpness and wide coverage could dramatically improve the picture. That's when astronomer Jean-Philippe Beaulieu, from the Institut d'Astrophysics de Paris, proposed something unconventional. What if Euclid, designed for an entirely different kind of astronomy, briefly turned its incredibly sensitive visible light camera toward our own galaxy's crowded heart instead? Idea worked, but that wasn't the biggest surprise. Part 3 is where the ambition of the whole plan really escalates, because once mission planners agreed to the idea, they didn't aim for something modest. On March 23, 2025, Euclid spent a single, carefully planned observation window, roughly 26 hours in total, capturing a mosaic made up of 9 separate images stitched together, each one covering a patch of sky larger than the full moon as seen from Earth. Altogether, the finished mosaic covered an area equal to 22 full moons, an enormous slice of sky for any single observation to capture in this much detail. To understand just how impressive Euclid's camera really is, compare it to the Hubble Space Telescope, one of the most famous and capable instruments ever launched. In terms of raw sharpness and sensitivity, Euclid's visible light camera performs similarly to Hubble's own wide-field camera. But here's the key difference. Each single image Euclid captures covers an area of sky roughly 270 times larger than what Hubble can capture in one shot. That combination, Hubble-level sharpness paired with an enormously wider field of view, is exactly what made this particular image possible. A telescope with Hubble's narrow focus alone would have taken an impractical amount of time to cover this much sky in this much detail. Euclid could do it in about a day. When the finished mosaic finally came together, the numbers were staggering. The completed image resolved more than 60 million individual stars, each one a genuine real point of light from our own galaxy's crowded core. Then investigators uncovered something nobody expected: at least not on this particular scale. Part 4 is where the story reaches its biggest turning point, because 60 million stars, as astonishing as that sounds, actually reveals something almost humbling once you understand the full context. According to astronomers studying the Milky Way, our galaxy contains somewhere in the range of 100 to 400 billion stars total. That means even this record-breaking image, showing more individual stars than any visible light photograph of our galaxy center ever taken before, still captures less than 1% of the stars that actually make up the Milky Way. Sit with that for a moment. An image containing 60 million real, individually resolved stars represents barely a fraction of our galaxy's true population. The Milky Way isn't just big, it's almost incomprehensibly big, on a scale that makes even a landmark record-setting photograph feel like a tiny keyhole glimpse into something far larger. The image itself revealed striking visual detail too, scattered throughout the glowing fields of golden starlight. Astronomers could clearly see dark, irregular patches cutting across the frame. Dense clouds of gas and dust, called dark nebulae, effectively blocking the light from stars behind them, like ink stains smudged across a canvas of stars. Toward one section of the mosaic, the colors shifted into deeper purples and reds, subtle clues about the different types of stars and material populating that part of the galactic bulge. But the scientific value of this image goes far beyond its visual beauty. Tucked within the frame, astronomers identified 51 already known planetary systems, planets previously discovered using ground-based telescopes, now visible within Euclid's much sharper, much wider view. According to Bolu, having these confirmed systems captured inside the same image will help scientists directly study and refine measurements of planets already known to exist, while also assisting the search for entirely new ones hiding in the same crowded field.